One thing I'm curious about, and curious actually how Weaviate looks to solve some of these is beyond just like relevance, right? I think there have been more emerging retriever type paradigms or patterns that at least people are starting to realize, okay, we need more than just vector search, right?
Yeah.
Some maybe like vector plus like metadata or tags or attributes,
Yeah.
like some hybrid blend. Could you share maybe a little bit about how you all are thinking about this type of problem?
Yeah. So there's multiple ways. So vector search is nice to solve one particular problem. Right? If you want to search over data that your database understands, vector search solves that problem. It's not very good for exact matching, right? So for example, if you've got a e-commerce platform and a person comes along and says, I want the product with this serial number, vector search has no idea what to do with that. For that, you would much rather have like keyword matching or metadata search, which is what's more classically accepted. So one way that we're dealing with this is that Weaviate actually has this hybrid search functionality where you can specify that I want to use a bag of words model like BM25 or a TF-IDF model that does classical search. It just matches which words are present, which ones are not present. Um, or you could choose completely vector search, where it just looks at the vector and it says these are the nearest vectors, and so they're semantically similar, and this is what might be relevant. In hybrid search, you take the best of both worlds, right? And I think hybrid search is practically what you would want to use for any application, because in hybrid search you can go in and modify how much of the retrieved result you want to be weighted based on the, uh, the exact word matching. So sparse search versus dense search or dense retrieval. And if you want for your application to be a little bit more vector searchy, you can increase the alpha or decrease the alpha if you want to be a little bit more exact word matching. So I think that's one solution to this. The other solution, so that works to a degree, but like you said, some applications actually require searching over metadata. Right? If I'm only interested in flights that left after 2021 or before February, um, you know, exact word matching is not going to help because all that information is stored in a non-vectorized metadata field. So for that, we have this thing called pre-filtering. Right? So what you could do is similar to structured databases like SQL, where you could filter and show only the relevant concept. In Weaviate, you can pre-filter and you can say, based on the values of this metadata field, only sub-select these out of, like, say 10 million objects, sub-select the ones that have a date greater than this number or less than this number. And then let's say you have 50,000 objects of interest that are selected, and then you do vector search on top of those pre-filtered objects. So we internally use this to make vector search more efficient, but you can also kind of programmatically use this to say, filter these based on this metadata, and then perform vector search on top of what's returned. Um, so that's useful because if you're doing multilingual search, for example, and you only want French results to be returned, you can say filter based on French, and then rather than the 10 million objects you've stored in here, now you only look at the 500,000 French objects, and then you do semantic search over those French objects, which I think is another way to solve this. The filtering itself is not like, I wouldn't use a vector database for just filtering, but if I wanted to filter and then vector search, that's where I would want a vector database.
Yeah, yeah, I think this combination of these classical techniques, because these sort of things have been around for ages, right?
Yeah.
Plus, like some of these new capabilities have been more recently expressed through like vector databases and such. Yeah, the combination of them can build a very powerful application, and it certainly is very context dependent, right? For e-commerce, if you're doing, yeah, like traveling, or you have all this, like, either keywords or metadata.
Yeah.
Or even just concepts, right? That can be expressed as vectors or embeddings. It's all very interesting. I'm sure a lot of app developers have to wrestle with or figure out like how to best do this for their application.
Yeah, and then even if you look at technologies that are not as new as vector databases, but you would benefit from representing those in a vector database. So for example, if you have a graph database, right, usually you have information in your data set that can be captured using these graph connections, these edges between nodes, and a vector database doesn't support that, right? But in Weaviate, we have this concept where you can actually create a class and you can refer to other classes from that class. So, and the utility of this is if you create, let's say you have a user class and you've got a product class, right, on your e-commerce platform. When a user creates a new platform, they get their instance, and anytime they buy a product, that creates this kind of knowledge graph kind of edge between that user and that product. So now you have a way to encode these relationships between objects within the vector database as well, which natively a vector database doesn't use or doesn't need to use, but we've added it in so that even if you have this kind of relational this graph structure to your data, you can still encode it. And one of the useful ways that we've seen people use this is for recommender systems. Right? Like a user comes in, they buy 3 products. Out of the millions of products that you have, what are you going to recommend to that person? You can actually determine the user's vector as an average over all the products that they've bought, and then just use this person as a query into your database and say what other objects are close enough to this average of product query to recommend to you, right? And this is good for short-term kind of instance-based recommendations, not for long-term recommendations. But yeah, I think that's also interesting because we're thinking not just about filtering and vector search, but also how you encode this graph structure into the database as well.
Yeah, I think that's super fascinating, especially for those type of recommendation type applications where the old ways of doing this, right? You probably would do some sort of like collaborative filtering type approach, and
Yeah.
very much like, okay, I clicked on this, or these entities, these objects have these common features across each other. And
Yeah.
but now if you're able to express it, right? I think a very future looking thing is, right, maybe the vector database companies like Weaviate are going in this direction, is where you create data, or you create this type of like synthetic
Mm-hmm.
representation of something based off of all the vectors and all the other pieces that you've accumulated over over usage, and that becomes, you now become like a data provider, or you become a
Yeah.
whatever data broker, if you will. And um, I think that could be very intriguing for future applications.
Yeah, so it's interesting because when I joined the company, it was before the large language model craze. We were in the diffusion model craze, where given a text query, text input, generate a picture for me, like so things like Stable Diffusion, DALI, um, and there I was thinking about an application that's similar to what you're saying, where rather than regenerate for every incremental change in the input string, what you could do is have a vector database that indexes and stores, understands generated concepts and the corresponding queries that generated them. Right?
Mm.
So the next time you have the nth person that comes in and passes in just like a slight modification onto a query that you already know, that you've already generated with, then you can return to them. It's a retrieval task as opposed to a generation task, right? And they get relevant things, but rather than you having to like inference and forward pass through the model and costing a ton of money, you have this back end of a retriever, and then you could then combine the vectors of these representations to then do better search, right? Because you know that the vector representation for this image and this image is quite good and it encodes the knowledge. What if you try to combine these concepts? If you have the vector image representation for a dog in a park and you combine the vector and you maybe use that to condition the generation, you might get better results. So that leads into what you're saying about like synthetic data generation using a representation of all the data that you've already stored. It's interesting. I wanted to know a little bit more about semantic kernel as well. So was semantic kernel an internal project, and then how did semantic kernel get to where it is now? I was interested in learning more about that as well.
Yeah. So it started off as an incubation inside the office of the CTO. So that's the team that the group that I'm in. And as you can imagine, the Octo group at Microsoft is pursuing many different lines of thinking or ideas. And Microsoft had early access to GPT-4. And while a lot of people were already building applications on GPT-3 and previous versions, I think GPT-4 represented this huge step function in terms of the types of things that you could do, right? The reasoning powers and all that. So we found that, yeah, that you could build applications, AI applications, right? Semantic applications that looked very different than how things were done before. And hence we kind of took all these learnings. We did a lot of prototypes, but we eventually, abstracted a SDK called, hence the semantic kernel, and we open sourced it, right? I think in like early March or so, because we realized that it doesn't really make sense for us to just like keep it in the house. This space is moving so quickly. The community has a lot of great ideas, right? We want to work together with them to do that. And we also want to service, right, the app developers who are like in C Sharp, we have Python, Java, and all that. Those people who may not always or have not always been able to participate in all the AI work or all AI development. And now they can, right? Or at least more concretely. So yeah, so that's where Semantic Kernel really started. And now, it's out there. A lot of teams, a lot of companies, both internal to Microsoft and external, are taking real dependencies on it, pushing things to production. It's exciting. Yeah, we're just all along for the journey.
Yeah, it's pretty cool because I kind of looked at the structure of how you're building it out, and you're essentially kind of making decisions around what aspects you want to support. So, for example, the planners that were implemented in C Sharp, now you're kind of porting them over to Python, and then you're adding the OpenAI function calling to better support the planners so that they can call the functions appropriately. I guess my other question is which interesting applications have you seen people work on with semantic kernel, or what's the most common application that people are using semantic kernel for?
Yeah, I mean, as you could probably tell or know, that like chatbots over your own data or enterprise chat over your own data is
Yeah.
like the most common type of application. But I like to describe it as like I'm more interested in the ABCs, anything but chatbots. So it's like how can you use just like AI maybe with
Yeah.
semantic kernel? So the strong pieces of like these AI models can do information synthesis, right? Being able to process and digest a lot of information, right? With these models that have 100,000 token windows, they can ingest a lot of data, and now you can use that to maybe create some downstream content, or you can have that be a brain, right? That can now reason
Yeah.
or do stuff like for you. There's been a lot of talks from the AI community around like agents and things like that. Super fascinating. But in terms of like the enterprise adoption of it, I mean, people are still just trying to feel like, I just want RAG. I just want
Yeah.
to, commercialize
Perfect it.
that or perfect that. Yeah, get that working robustly. But then these other things could be coming in down the line.
Yeah, it's interesting where a concept as simple as RAG, there's so much work that's going on inside of it as well. Like every week, there's new work around RAG. Like one of the things that I mentioned in the blog was rather than just ragging once, you rag per token. So you get a word and then you say, okay, I don't know anything. I'm going to retrieve context and then I'm going to rag for the next token, which is I think overkill. So then they developed a algorithm to determine when to rag and when not to rag. And then if it determines that the large language model is going off the wheels and just generating BS, it'll rag. They'll kind of execute a rag statement and then it'll bring it back on track. One of the other things that I was mentioning earlier that I'm really excited about is this multimodal RAG. Right, so we know that when they released GPT-4, one of the co-founders of OpenAI it showed this kind of hand-drawn app, and then it
Yeah,
wrote the
yeah.
code for the app. And I haven't seen that many applications of it. Like people are just using the language part of it, I
Hmm.
want to see the multilingual components of it being put into action, and then like further down, I want to see where people can get to with multimodal RAG, retrieving a audio file and then having the large language model listen to it and then generate or answer the question as a
Hmm.
function of that. I think that is like undiscovered territory right now. Like I'm not seeing
Yeah.
much work done there.
Yeah. Yeah. I mean, I can even just imagine, like, I'm sure the intelligence agencies, if they're listening to this video, they're probably like thinking,
Very
oh,
useful.
we can use this to, process lots of data,
Yeah.
lots of video, lots of audio, and then do some or take some sort of action from it. So I think the evolution of these foundation models, it will open up a whole line of different applications. Now, the question is like, for projects or products like Weaviate and the other parts of the Microsoft calls it the Copilot stack, right? Or just the infrastructure, right, for building large language models applications. Will the ones that are popular today still be popular when the models get even better? Or will
Yeah.
the model be so good that it kind of, you know, it,
Internalizes everything. Yeah.
yeah, and it defeats the purpose of having specialized engineered architectures for
Yeah.
this. So
I feel like I guess I don't know enough about this to even have an opinion, but it feels like the theoretical thing, the end game is to have a model that can do everything, but it just seems a lot more practical to have a model that can tool use, and the tool is what's specialized, right? Rather than have the model be able to code up and create a calculator and then use the calculator, it just seems a lot more doable to say, here is a tool. I don't need you to invent the tool. I just need you to
mhm,
learn how to use and when to use the tool. Um,
yeah.
but that is, yeah, that is a good question. This is the same kind of conversation that people are having in terms of long context versus retrieval, right? If you have infinite context, then why you need retrieval? Um, and this is, I feel, also an open question because we don't know how well models use context. Do they
Hmm.
use all of the context equally well? Do they use? There was a paper that was published around this as well, where they showed, I think it was called like Lost in the Middle or something like this,
Yeah,
where
yeah,
they showed that context in the beginning or at the end was
yeah, yeah.
over referenced, and the stuff in the middle was under referenced.
Mhm,
Um, I feel like it goes back to what we started off with, right? You have industry and academia that are kind of
mhm.
pushing each other, and we're kind of ping ponging in the middle to see, oh, this is state of the art now. Oh no, this is great, and it's pretty
Yeah,
interesting times.
yeah. Very fast moving space.
Yeah.
Well, Zane, thank you so much for this time. I guess as we wrap up, for the listeners, for the people who want to follow you, want to see more of what you're doing, where can they find you?
Yeah, so I'm on LinkedIn, Zain Has. I'm on Twitter, Zain Hasan 6, Zain Hasan 6. And then you can also join our community on Weaviate. If you build something cool with Weaviate, we'd love to hear about it. Right, so tweet at us, let us know if you want to come onto the podcast, if you want to join our monthly. We call it Weaviate Air. You want to join that show and you want to show off to the community what you've made, we'd welcome that as well. And in terms of what I'm thinking about doing next with Semantic Kernel, I want to get into the agent building stuff. Like because I wanted to see, I wanted to learn Semantic Kernel, and like you said, I started off with the C, but now I want to do the ABC, right? Anything but the chatbots. So now I want to get to the agent stuff. And I was waiting on the integration of the OpenAI function calling. And do you guys have that? I think that was almost being done, right?
That's in OpenPR right now, so
Yeah.
you could play around with it. Yeah, it because it requires a bit of an architecture change
Uh-huh.
uh, in overall semantic kernel, but yeah, we do intend to integrate it soon.
Yeah. Sounds good. I was watching one of the office hours that you ran, and I know that was one of the priorities. So I'm waiting for that, and then I want to build some agents, and then uh, hopefully I can come up with something cool. And the idea is to release the notebooks into the third party ecosystem for semantic kernel, so that as people are using it, maybe they can build up their own applications around it. So um, I think it'll be fun.
That'll be cool. Yeah, and we can have you again to show off the latest that you make.
For sure. For sure. Hopefully something multimodal next time. I want the large language models to be able to consume images and audio files, and then I want to integrate that into the component. Recently, we integrated a new multimodal model from Meta that can understand audio, images, video, and right now I'm kind of hacking together the multimodal component of it. It'll be cool for the tools that we have, Semantic Kernel and Weaviate, to support multimodality natively. And then you could have like a line of code that does multimodal RAG, and then I think that would be super cool to give conference talks around, do podcasts around. So hopefully next time I'll have that and we can show it off.
Yeah, yeah. And also, all the stuff in between too. It doesn't have to show the end thing
Yeah.
always. You can always help people along the journey, right? I think that's a key thing. Cool. Well, thank you, Zain, again. And yeah, looking forward to future collaborations um, and more from you. So
Awesome. Thanks, Alex.